Hello friends, so in last class we saw the higher order linear differential equation with constant coefficients and we derived the solution also. So in today's class we will carry on our discussion. So we saw that the general form of the equation was similar to this. So this is a higher order linear differential equation with constant coefficient. So you can see these are the constant coefficient. So we have derived this. So in place of single differentiation with respect to x, we replaced by capital D. In place of double differentiation with respect to x, we replaced by capital D square, and similarly so on. So you can see here this equation can be written like this. So now in the next step we can take out y common, and so we are left with this part. So this is the fd part, which is a function of capital D. So and we saw the how we derived this solution. So if you have not watched that video and you want to know the solution, how we have come to the solution, you can watch the first part of the video. So here y is equal to c1 e to the power of m1x plus c2 e to the power of m2x plus dot dot so on. So here m1, m2, m3, these are all the roots of fd equal to 0, where fd is the polynomial in D. So in today's class we will discuss the special cases. So we will see what happens when the roots are imaginary. So we will derive a formula for that. Then we will see the case when the two roots are equal. For example, m1 is equal to m2. Then we will see the case in which the three roots are equal. That is m1 is equal to m2 is equal to m3. Then we will see a general case where suppose two roots are equal, then other two roots are equal, and there is a third root. So we will derive the different cases now. Okay, so let's see our special case number 1. So what if our roots are imaginary? So here you can see m1 is alpha plus iota beta and m2 is alpha minus iota beta. So we will substitute m1 and m2's value to derive our formula. So y is equal to c1 e to the power of m1x plus c2 e to the power of m2x. So in place of m1 you can write as e to the power of alpha plus iota beta x plus c2 e to the power of alpha minus iota beta x. Now you can take out e to the power of alpha x as common from both sides. So you can take out e to the power of alpha x common. So inside you will be left with c1 e to the power of iota beta x plus c2 e to the power of minus iota beta x. Now we will use our expansion formula of e to the power of iota theta, which is cos theta plus iota sin theta. So when you use this formula here as well as here, then you will get e to the power of alpha x as it is c1. So here you will get cos beta x plus iota sin beta x plus c2. Here you will get cos minus beta x plus iota sin of minus beta x. Now one more formula that we have to use is, we know that cos of minus theta is equal to cos theta, and sin of minus theta is minus sin theta. So I hope that you also know this basic simple trigonometric formula. So we will use this formula here. So e to the power of alpha x c1 cos beta x plus iota sin beta x plus c2. Here it will, this minus will get cancelled out, so it will become cos beta x plus, sorry, here it will become minus iota sine beta x. Now if you take cos beta x as common, so you will get e to the power of alpha x c1 plus c2 cos beta x. And if you take sine beta x as common, then you will get c1 minus c2 sine beta x. So now you know that this will also be a constant only. So let's replace this with c1 c2. So it will become e to the power of alpha x c1 cos beta x plus c2 sine beta x. So if you want to remember this, you can simply remember like e to the power real part into x, then c1 cos of imaginary part into x plus c2 sine of imaginary part into x. So now let's solve one problem on this. So for example, you can try this for example. D square d plus 1 into y is equal to 0. So let's solve this. So you know that this is our fd. So if you find the roots of this d, so you will get minus 1 plus minus root d square, which is 1 square minus 4 into 1 into 1 by 2. So you will get minus 1 plus minus, here you will get root 3i by 2. If you compare this with alpha plus beta, if you compare with this, so you will get alpha as minus 1 by 2 and beta, which is your imaginary part, will be root 3 by 2. So now if you use this formula to get our solution, so e to the power of real x, so real part is minus 1 by 2 x, then c1 cos of root 3 by 2, the imaginary part of x, plus c2 sine root 3 by 2 x. So that's our solution. So okay, so now let's see other special cases. So what if the two roots are equal, or what if the three roots are equal? So if the two roots are equal, then the solution will become y is equal to e to the power of m1 x bracket c1 plus c2 into x. And if in case of there are three equal roots, then this will be the solution. So let's derive this both one by one, and then you can generalize this. So we had our equation as fd into y is equal to 0. So this fd can be written as d minus m1 into d minus m2. So we are splitting this. So now this m1 and m2 are same. According to this, we are solving the first. So d minus m1, we can replace m2 by m1. Now here what we will do is we will assume this part as z. So we will take d minus m1 into y is equal to z. So you can expand this also, dy by dx minus m1y is equal to z. So this is our assumption. So what is the benefit of this assumption? So let's solve. So you will get this equation will become d minus m1 times z is equal to 0. And in last class also we have seen that the solution to this will be equal to z is equal to c1 e to the power m1x. Now what we will do is we will substitute back from here the value of z. So z was dy by dx minus m1 y is equal to z, and z is equal to c1 e to the power of m1x, e to the power of m1x. So this is a linear differential equation, and it is very easy to solve, and we have learned how to solve these types of linear differential equation. So first we will find the integrating factor. Integrating factor will be e to the power of integration px into dx. So this is our px term, e to the power of minus m1 into dx. So it will, since m1 is our constant, we will get e to the power of minus m1 x. Now our formula for the linear differential equation is y into integrating factor, then q into integrating factor integrated by dx plus c. So this is our q. So we will write y into integrating factor is e to the power of minus m1 x, then q is c1 into e to the power of m1 x, c1 into e to the power of m1 x into integrating factor. What is our integrating factor? Integrating factor is this one. So e into minus m1 x into dx plus c2. So you can see this and this will get cancelled, you will get 1. So y into e to the power of minus m1 x, you get c1 dx plus c2. So now you can bring this in right hand side. So you will get y is equal to e to the power of m1 x c1 x plus c2. So now you have understood the derivation in case m1 and m2 are equal, two roots are equal. So from using this only we will derive what will be the solution if the three roots are equal. So now if three roots are equal, m1 is equal to m2 is equal to m3. So in that case fd into y can be written as d minus m1 d minus m1 d minus m1 into y is equal to 0. So again similarly we will assume this as z. So d minus m1 into y as z, or you can also write dy by dx minus m1 y is equal to z. So now this will become d minus m1 into d minus m1 into z is equal to 0. And just now we have found if the two roots are equal, that is m1 is equal to m2, then we will have this as our solution. So z will be equal to e to the power of m1 x c1 x plus c2. Now you can substitute this back, this value of z here. So you will get dy by dx minus m1 y is equal to e to the power of m1 x c1 x plus c2. So again this is our linear differential equation, just like the previous case. This is our qx term and this is our px term. So we will again similarly find the integrating factor, which is equal to the previous case, e to the power of integration of px dx. So our px is minus m1 e to the power of minus m1 dx. So you will get e to the power of minus m1x. Now we will multiply y into integrating factor, and on the RHS side q into integrating factor, and we will integrate with respect to dx. So you will get y into integrating factor is e to the power of minus m1x, then q is c1x plus c2 and e to the power of m1x, and our integrating factor is e to the power of minus m1x. So you can see here minus m1x, then dx plus, you can say c3, another constant. So here you will get y into e to the power of minus m1x is equal to, so here again this will get cancelled with this, you will get 1 c1x plus c2 dx plus c3. So when you integrate this thing, this polynomial, so you will get y into e to the power minus m1x. So here you will get c1 x square by 2 plus c2 x plus c3, and again c1 by 2 will be another constant, so you will be let it be another constant. So you can see finally you will get, if you take this to the right hand side, e to the power of m1x c1 plus c2x plus c3 x square. So in case 3 roots are equal, you will get this. So now let's generalize this. What if there are 4 roots equal? m1, m2, m3, m4. So you don't have to calculate, you can just generalize it. So you will get y is equal to e to the power of m1x, then c1 plus c2 x plus c3 x square plus c4 x cube. Just only one last special case is, what if 2 roots are equal, then 2 other roots are equal and 1 root is different. So in that case, we know that in case of 2 roots equal, we get y is equal to c1 plus c2 x into the e to the power of m1x. Similarly, plus, because these are 2 different roots are equal, here you will get c3 plus x times of c4 into e to the power of m3 x plus c5 e to the power of m5x. So now I hope that you can similarly play with this and get different possibilities and different permutations and combinations. So now we will come to questions. Okay friends, so we will quickly practice some questions so that these concepts implant deep into our minds. So we have 4 questions. You can practice these questions. First you can try this question by yourself, then I will provide you with the solutions. Okay, so first we will solve this question. So this is the simplest of all. So what we will do is, we will first equate this fd is equal to 0. So m square plus 5m plus 6 is equal to 0. So you know that you can write this into the factorization form, that is m plus 3 into m plus 2 is equal to 0. So your roots are, m is minus 2 and minus 3. So we know that our solution will be y is equal to c1 e to the power of m1x plus c2 e to the power of m2x. So you can replace m1 m2, c1 e to the power of minus 2x plus c2 e to the power of minus 3x. So that's the solution. So now we will go to the next question. Okay friends, so now we will see the second question. So this is a little better question than the earlier one. So here let's find the roots. M cube plus m square plus 4m plus 4 is equal to 0. So by hit and trial you can factorize this. So here we will put minus 1 if you see. So you will get minus 1 whole cube minus 1 whole square plus 4 times of minus 1 plus 4. So you can see that minus 1 is satisfying this. So here you will get minus 1, here you get plus 1, here you get minus 4, again you get 4. So overall you get 0 because this get cancelled by this and this get cancelled by this. So this is just to make sure that how we are getting the factorization. So you can have your own method. So this is a very simple factorization. So m plus 1 will be one of the factor. Now what we will do is, we will divide this m plus 1 with the m cube m square plus 4m plus 4. So it will become m square. So it will become m square into m cube, and m square into 1 plus m square if you see, this will again get cancelled. Again 4m plus 4 is left, so we will multiply by plus 4, so it will give you 4m plus 4. So you can see this will get cancelled. So we have done this only to find the factorization. So the factorization of this entire polynomial will be m plus 1 into m square plus 4. So if you see the roots, so you will get roots as m minus 1 using this, and from here you will get plus minus 2i. So once you will get 2i, and other time you will get minus 2i. So now we want to write the solution. So our solution will be y is equal to, for this distinct root we know c1 e to the power of m1x, and here you can see we have the imaginary roots. So one of the root is 0 plus 2i, another is 0 minus 2i, where 0 is the real part and 2 is the imaginary part. So our formula was e to the power of alpha x c1 cos beta x plus c2 sin beta x, where alpha was the real part and beta was the imaginary part. So here alpha is equal to 0 because you can see the real part is 0, and beta is equal to 2 because the imaginary part is 2. So just replace this. So here y is equal to c1 e to the power m1 will be minus 1 minus x plus e to the power alpha is 0, so this will become 0 to the power of x c1 cos 2x plus c2 sin 2x. So this will become 1. This will become 1. So this is our final answer of the question. Okay, so now let's solve this third question. So this is also a very good question. You can give it a try. So now let's start. So m to the power 4 minus 4m square plus 4 is equal to 0. So you know that this is of square form, that is m square minus 2 whole square. So we know that a minus b whole square is a square plus b square minus 2ab. So it is from there. Now it can be further be written as m square minus 2 into m square minus 2, and separately you can find the roots of from here. So here you will get m is equal to plus minus root 2, and from here also you will get m is equal to plus minus root 2. So you can see that you have 2 times plus root 2 and 2 times minus root 2. So now we know that in case when our two roots are equal, then our constant is c1 plus x c2, then e to the power of m1x. So keeping that in mind, because 2 times our roots are equal, here also, our y term will become e to the power of m1x. So first m1 is root 2 x, then c1 plus x c2 plus, now for this the second one, e to the power of then again m2x. So here m2 is minus root 2x, and here we will use another constant, that is c3 plus x c4. So this is our final solution. So I hope that you have understood this. So this was a little tricky question. Okay friends, so now let's see the fourth question. So let's solve this. So here you can write this as m square plus 1 whole cube whole cube is equal to 0. You have to solve for this. You want to find the roots. So you can expand this as m square plus 1 into m square plus 1 into m square plus 1 is equal to 0. So you know that if you solve for this, you will get m is equal to plus minus iota, and similarly for this also you will get the same, and this also you will get the same, plus minus iota plus minus I. So here you have 3 times repetition, 1 2 3, and in case we have 3 times repetition, we know that we replace our c with c1 plus c2x plus c3x square. So first what would be, and also our roots are imaginary also. So first let's see how we will write for the imaginary one. So y is equal to, we write e to the power of alpha x, but alpha is 0 because you can see the real part is 0. So 0 into x, then c1 cos of beta x, so beta is 1, so it will become x, plus c2 sine of beta x, again beta is 1, so sine x. Now this c in both places you have to replace with this type of expression, that c1 plus c2 x plus c3 x square. Here also you have to replace by similar expression. So, and this will become equal to 1. So you can see y is equal to c1 plus c2 x plus c3 x square into cos x, plus here let's give another constant, c4 plus x c5 plus x square c6 into sin x. So this is our final solution. So this is our final solution. So I hope that you have enjoyed the session. So for more such videos you can go through my other videos also. Till then, thank you. Bye bye.